Okay, we're going to be looking at the 5.5 practice quiz, and I'm giving you a good visual right now, aren't I? It looks like this. So if you, for some reason, don't have your copy, you can go download it, of course, on It's Learning, or just write on an extra piece of paper. It doesn't really matter. So we're going to be going through this, and I may skip things here and there, just maybe explain them in words. There will be a key on It's Learning, so you can also look up the key if I have skipped something or you need a different way to see it. Okay. So 1 through 6, you're just looking at what are all the vertical angle pairs, for example. And so you don't have to list them all. This is more just a refresher for you, and then the relationship that comes with that particular type of angle, right? So vertical angles are angles that share a common vertex and are across from each other, okay? And so I want you to think like vertex vertical, VV, vertex vertical. So for example, angle 1 and angle 3 are vertical. Right, so they share this vertex right here, and they're across from each other. Angle 2 and angle 4 are vertical. Angle 5 and angle 7 are vertical. Angle 6 and angle 8 are vertical. So you would say like angle 1 and angle 3, right? And so you would just, there's a bunch of them. You could just name all of these angles that I just said right there on that line. And of course, there may not be room, so you could work on a separate sheet of paper. And the relationship of these vertical angles, notice it's acute to acute, obtuse to obtuse. And if these are parallel, which we will assume they are, then we can say that they are congruent. And remember, congruent means they are equal to each other. They are the same measure. Corresponding angles are angles that are in the same position, right? So if I'm looking at this set of angles and this set of angles, remember if these are, if these lines are parallel, these 4 angles will match exactly with these 4 angles. So 2 would match exactly with 6, 3 would match exactly with 7, 4 with 8, and 1 with 5. I could literally cut this in half and put 1, 2, 3, 4 on top of 5, 6, 7, 8, and it would look exactly the same. So corresponding angles are in the same position. So 2 is top left, 6 is top left, so they're corresponding. So an example of this would be like angle 2 and angle 6, right? And again, there's actually 4 of these, right? 2 to 6, 3 to 7, 4 to 8, and 1 to 5. And corresponding angles are also congruent to each other, which means that they're equal. They're the same measure. Number 3 is alternate interior angles. Alternate interior angles, remember, when you think alternate, you should think opposite the transversal. Interior would be inside the parallel lines. And I know this is a little confusing because that sounds like it could be 3 and 4, but 3 and 4 are a linear pair. So alternate interior would be, for example, like 4 and 6, or 3 and 5. And remember, alternate interior is where we make the Z, and the inside of the Z is your alternate interior. Okay? So your examples here would be like angle 4 and angle 6, and then angle 3 and angle 5. Those would be your examples of that. And these angles are also congruent. These angles are also equal. So keep in mind that all your acutes are equal to all your acutes, right? So 1 and 3 are acute, they're equal. 5 and 7 are acute, and they're equal. And they're all equal to each other. So if one's 30, they're all 30. And then your obtuses are equal to each other. So 2 is equal to 4. And 6 is equal to 8. And they're all equal to each other. So 6 is 120, 2, 4, 6, and 8 are all 120. All right, alternate exterior. So same thing here where we say, okay, alternate means opposite side of the transversal. And this time exterior means kind of outside these parallel lines. So on the outside, 1, 2, 7, and 8 are outside. So alternate exterior would be 1 and 7, and you can see marked with blue here that they're equal to each other. And 2 and 8 would be the other pair of alternate exterior. So we would say angles 1 and 7. And then we might also say like angles 2 and 8. And these are also congruent. These are our big 4 congruencies that we talked about all week. Vertical corresponding, alternate interior, and alternate exterior. Then we have our 2 that are a little bit different. And they are same side interior and then linear pair. So same side interior, so you think same side, that's same side of the transversal, and then interior means the same thing. It's inside the parallel lines. So in this case, when we say interior, we're talking about 3, 4, 5, and 6. So same side interior would be like, for example, 3 and 6 and 4 and 5. So angle 3 and angle 6, and then angle 4 and angle 5. And you can see here they're marked in different colors, 3 and 6, one's blue, one's pink, so they're not the same measure. And one's acute, one's obtuse, so that's pretty obvious, so they're definitely not congruent or equal to each other. But their relationship is that they are supplementary. They add to get 180 degrees. So what I would say here is their relationship is that they are supplementary, or they add to get 180. And then the linear pairs, there's a ton of these, and I'm not going to list them all. But it's anytime you've got 2 or more, or I guess we're saying pairs, so 2 angles that come together to create a line. So 1 and 2, 2 and 3, 3 and 4, 4 and 1, 5 and 6, 6 and 7, 7, 8, 8 and 5. Anytime they're side by side or adjacent, sharing a ray, and their opposite ends make the line, then they have a linear pair. So I'm just going to give a couple of examples here, like maybe 1 and 2, you can see that, but also 1 and 4. I just wrote the craziest thing. Angle 1 and angle 4, right? And then there's a bunch more, like I just said. And we talked a lot about this again, but again, we see here with those linear pairs that we have a blue and a pink together, a blue and a pink together, a blue and a pink together every time, right? Acute and obtuse together. And so we know they're supplementary, or 180 degrees. Number 7 says, use the diagram above to determine all the angles if we know the measure of angle 1 is 32 degrees. Okay, so I'm just going to redraw it here so I can write on it. So, assuming that these are parallel, if we know that the measure of angle 1, which is this acute angle right here, is 32 degrees, what that tells me is that all these little acute angles, I'm going to zoom in here, will also be 32 degrees. So you can see 32, vertical to 32, these are equal, so that has to be 32. Alternate interior, I can jump down here to this one. It has to be 32. And then I can vertical across to here, so it has to be 32, right? So 1, 3, 5, and 7, angle 1, angle 3, angle 5, and angle 7 all are equal to, and I'm just shorthanding this, but 32 degrees. Okay? Now, in order to find the rest of them, I need to recognize that together these two angles make a line. And so in order to find this one that's missing, what I can do is I can just take 180, which I know is the linear pair, the supplementary relationship, and take away what I do know to find out what I don't. So I'm going to subtract 32 from that, and that's going to give me 148 degrees. So that tells me that this angle right here is 148 degrees. And then every angle that's obtuse in this picture will also be 148. So vertical from that, 148. Alternate interior, 148, or you could say corresponding. And then vertical for that, 148, or I could say corresponding to that one. But you can kind of see here that all those obtuse angles will be 148 degrees. And if I look up in that picture, that's all my evens. So angle 2, angle 4, angle 6, and angle 8 will all be 148 degrees. Okay, moving on to the next one. It says use the diagram to solve for x, then find each one of the angles. And so we worked on this on Friday and a little on Thursday. So in this diagram, I want to determine the relationship of these. Well, here's a vertex and here's a vertex, and they're both in a top right position. So that tells me that their relationship is that they are corresponding angles with each other, which we just reminded ourselves means that they are congruent, or they're the same measure. So that means in order to find x, I can just set them equal to each other. So 2x plus 20 is going to equal 3x minus 10. And organize yourself if you need to by drawing that line through the equal sign. And then the very first step when you've got x's on both sides of the equation should be to subtract the smaller x from each side of the equal sign, right? Making that go to 0 like we want. Bringing down the 20. 3x minus 2x is 1x. I can write that 1x or not. It doesn't really matter. And then remember what you're trying to do. You're trying to get this x all by itself. So we're going to move the 10 away from it by adding 10 to each side of the equal sign, giving me x equal to 30 degrees, right? So that gives me x, and that's the first part of the problem, is just use the diagram to solve for x. And then from there on out, I'm going to go through and I'm going to find all these angles. And so in order to do that, what I'm going to do is I'm going to replace x with 30 so I can determine, what this acute angle is. So it's going to be in 2 times 30 plus 20. Right, it's just plugging 30 in for x. So that's 60 plus 20 is 80. Right, so what that tells me is that all my acute angles are going to be 80 degrees. And if I plug 30 in here, I should get the same exact answer. So 3 times 30 is 90. 90 minus 10 is 80 again. Just a little confirmation that I did my math right. And then I can label this acute angle also 80 degrees and this acute angle also 80 degrees. Then I can find all the other ones in this picture, all these obtuse angles, because I know linear pairs, right? So I know that if I combine these two angles right here, it should be 180, these two. So in order to find this obtuse angle right here, I'm going to take 180 degrees, take away what I know to find out what I don't know. Okay, so that tells me that my obtuse angles, and maybe I should use a different color here, so are going to be 100 degrees, right? And then vertical from that 100, that one's 100, and corresponding to that 100, that one has to be 100. Vertical from that 100, that one has to be 100. Moving on to number 9, use the diagram to solve for x and y, then find all the angle measures. I can actually find all them angle measures first, so I don't have to solve for x and y and then do that. And I can do that because I was given one of them, right? If I'm given one angle, I can find all the other ones. So for example, because I know this one's 125, I can now label all the obtuse angles 125. So this one's 125 degrees, right? Alternate interior to that one. I know this one's 125 degrees. Vertical from that one. I know this one's 125 degrees. And I bring this up because this may help you solve this equation, right? So if I know that this expression is going to equal 125, there's a quick and easy way that I can solve for this y. I could have also recognized that 7y plus 27 and 125 are alternate exterior angles, and so I could set them equal to each other. So I'm going to do a quick solve for y here. 7y plus 27 equals 125. And then just a quick solve. It's a simple two-step equation. Subtract 27, and I get 7y equals 98. And divide by 7, and y, see 7 goes into 9 one time with 2 left over. 7 goes into 28 4 times, so y is equal to 14. And I could check that by doing 7 times 14 and plus 27 and making sure that it's equal to 125. So there's my y. And then I need to solve for my x, and I'm going to go through here and I'm going to find my acute angle measures. So I know like these two together right here should be 180. So I can find this acute angle by taking 180, subtracting what I do know to find out what I don't know. So this would be 55 degrees. So that tells me that all my acute angles in this picture will be 55 degrees. 55 degrees, alternate interior 55 degrees, vertical 55 degrees. Okay, so that tells me I can solve for x because I know that my 15x minus 5 is going to be 55. So 15x minus 5 is going to equal 55 degrees. And then easy, quick two-step solve. So just add 5. Remember, you're isolating your x. You get 15x is equal to 60. Divide by 15. And you get x is equal to 4. And then you have x, and you have y, and you know every single angle measurement. All right, one more on the front. We're looking at the diagram to solve for x. And then find the angle measures. So again, just noting here that I was given the fact that this is 35 degrees, which tells me all the acute angles are going to be 35 degrees. So across vertical, angle 6 is going to be 35 degrees. Alternate interior, 35 degrees. Vertical, again, 35 degrees, right? And I can find all of my obtuse angles by saying, okay, I know together these two have to be 180. So I can find this obtuse angle by taking 180 degrees, taking away what I do know to find out what I don't. So let's see if I can subtract in my head here. That would be 45. So that means that all of my obtuse angles are going to be 145 degrees. So vertical would be 145. Alternate interior would be 145. Vertical from that 145, right? And this really sets me up for being able to solve for that x, because now I know that that 2x plus 35 has to be 145 degrees. So I can just 2x plus 35 equals 145, right? Little two-step equation. Subtract 35, subtract 35, and I get 2x equals 110. Divide by 2, divide by 2. X is equal to 55. Right? And I can again check it, just 2 times 55 plus 35 to make sure that I really do get 145. Okay, moving on. Question 11 says, use the diagram to name the relationships between the angles. Assume lines M and N are parallel. Assume lines A and B are parallel. Right, so these are parallel to each other, and these are parallel to each other. Let me mark 2 on that one. And it says name the relationship and determine whether they are congruent, supplementary, or complementary. So looking really quick, I may not have enough colors for this, but I'll try. 1 and 3, I hope we have just done this so many times you recognize this. They're across a vertex, so these would be vertical angles, and vertical angles are always congruent. Right? All right, let's look at angle 1 and 4. So this time we're looking at 1 and 4. Together, 1 and 4 make a line. And because together they make a line, we call this a linear pair. And a linear pair always gives you 180 degrees, which we call supplementary. Angles 6 and 16. Angles 6 and 16. So we've got 6 and 16. So I hope you can see this Z that these two make. We've talked about that Z. Anytime you can make a Z with the angles, these are called alternate interior angles. And alternate interior angles are always congruent angles. All right, so you can see they're both acute angles, so they are congruent. Let's see here. Angle 8 and 14, 8 and 14. So we're looking at this guy over here and this guy over here. And they're along this parallel line right here. And so I hope you can kind of see this here. They're on opposite sides of the transversal, outside the parallel lines. So we would call those alternate exterior. And both acute, again, congruent. Next, we're looking at angles 3 and 12. Angles 3 and 12. So here's 12. Here's 3. I marked on top of that. And so our transversal this time is this one, right? And so we're actually inside these two parallel lines A and B on the same side of this transversal N. And so we are same side interior or consecutive interior. Same side interior. And this time we've got an acute and an obtuse. So they can't be congruent. They have to be supplementary or add to 180. And let's see, I'll do 3. Again, I liked 3 apparently. 3 and 11. So if this is my vertex and this is my vertex, you can see they're both bottom right position. If I turn it just a little, you'll see bottom right position. So same position means that these are called corresponding angles. Corresponding angles, you can see it obtuse, obtuse, so they are congruent with each other. And then this may be a little hard to see. Let's see if I can use this yellow highlighter to do it. Name all the ones that are congruent with angle 1. So angle 1's on the pink, so vertical from that is 3. Alternate interior is 9. Vertical is 11. But then you've got this whole other issue because that was going along this line, right? But I could also go along this line. So alternate interior to 3 would be 5 this direction, and vertical to 5 would be 7. But then I could go this direction. Alternate interior would be 13, and vertical would be 15. So actually, every odd, obtuse angle in this picture is going to be congruent. So that would be angles, and I'm going to be lazy. I'm just going to do this. Angles congruent to 1 would be 3, 5, 7, 9, 11, 13, and 15 because of the relationship of so many paralines in one picture. All right, getting close to the end. Question number 12 says, assume A, B, and GX are parallel. So this guy right here is parallel to this guy right here. And it wants to know which angle is complementary to angle ABC. Let me get a color here. So ABC is this guy. This means equals 90 degrees, right? So we're looking for an angle that's complementary to this one. So I hope that you can see this here, but this 50-degree angle, right, which came just, all it did was it came from me saying I can take this 90-degree angle and subtracting away the 40 to get 50. And by the way, I knew this was a right angle because this is a right angle. And together they make 180. So 180 minus 90 would be 90. All right, so that would be 50. So angle XBC, oops, I don't know why I drew an A. Just going to do this. XBC is my angle that's complementary, and it's a 50-degree angle. 13, fill in the blank, always, sometimes, never. Notice that I said nothing about parallel lines, so we have to be careful, okay? Vertical angles are congruent. Remember, if I have two intersecting lines, vertical angles are across from each other, and this is always true. Vertical angles are always congruent. Part B says corresponding angles are congruent. So you might be tempted to say, yeah, that's always true, because if my two lines are parallel, right, then I have told you many, many times that corresponding angles are congruent. But if my lines are not parallel, right, so if it's like this, you can kind of see, I hope, maybe I should have done a more tilted line, that this angle right here is not the same as this angle right here. So can it be true? Yes. Does it have to be true? Not if the lines aren't parallel. So this is sometimes. And then C says adjacent angles are complementary. So I can have all kinds of adjacent angles, right? Complementary is adds to 90. So here are two angles that are adjacent, right? This one right here and this one right here that are 90. Here are two adjacent angles, right here and right here, that add to 180. Here are two angles right here that are adjacent that maybe add to 30. So adjacent doesn't tell you anything about the measurement. Adjacent only tells you that they share this common ray, right? They're attached to each other like two adjacent parking spots. So sometimes they're complementary, but they don't have to be. Last one. Two angles are same side interior angles. Their measures are represented by 2x and 3x plus 20. What are the measures of their angles? So I'm just going to draw myself a visual, okay? I'm going to draw myself two parallel lines with a transversal. where this is parallel and this is parallel. I'm sorry, it's about to get really loud because they're playing the music. So let's call this one 3x plus 20, and let's call this one 2x. Right? Same side interior means adds to 180. Oh gosh. I'm going to get loud for you. So I can add the two angles, set it equal to 180, and solve for it. Combine like terms. Subtract 20. And get 160. Divide by 5. And get, let's see, 5 goes into 16 3 times. 5 goes into 10 2 times, and get 32, okay? Now, it wants to know the measure of the angles. So once I get my x, all I have to do is go in and plug that back in. All right, so one of the angles, let's call it angle 1 for lack of a better word, is 2x. So it's 2 times 32, which is 64 degrees, all right? Angle 2 is 3x plus 20. So 3 times 32 plus 20. So that's 96 plus 20, which is 116. Right, so here are my angles, 64 and 116. You can't see that because the light's got all wonky. And just check to make sure they actually do add to 180. Let's see, 60, 70, 80. I feel good about it. Okay? All right, I hope the video helps. I will see you Monday for a quiz. Have a great weekend.